Hello and welcome to Measurements with a Gamma Scout in a nutshell. Having gained insight into the precise functioning of the GM tube in the device and how to utilize it for counting measurements, let us delve into measuring various gamma radiation with the Gamma Scout. In contrast to alpha and beta radiation, gamma radiation cannot be shielded completely. Consequently, it can be detected rather easily. Even when passing through lead, it is only attenuated. That means its intensity is merely lowered, as demonstrated here. Our Gamma Scout can even detect the emissions from our source when it is shielded by a lead brick. Gamma radiation transfers its energy over a longer distance, resulting in significantly fewer ionization along a certain pathway as compared to alpha radiation. Consequently, gamma radiation exhibits lower biological effectiveness compared to alpha and beta radiation. Generally, the emission of gamma rays is a consequence of a beta or alpha decay. Therefore, most radionuclides emit gamma radiation. In our episode on measuring beta radiation, we already have encountered some exceptions from that rule. In the natural decay chains of uranium and thorium, we can find notable gamma-emitting nuclides, in particular radium-226 or thallium-208. In addition, the radioisotope potassium-40 emits not negligible gamma radiation. As potassium is an element required by plants, animals, and humans, we find it in many foods as well as in our body. In some cases, by measuring these gamma emissions, one can determine the potassium content without chemical analysis. However, gamma emitters can also be identified from man-made sources. In some locations affected by the radioactive fallout generated by atmospheric nuclear tests and accidents such as Chernobyl, elevated activities originating from cesium-137 in foodstuffs can still be observed. For instance, in Germany, where we are located, many types of mushrooms, for example from the Bavarian forest, exhibit elevated cesium-137 activities. Similarly, this tea from 1986 contains cesium-137 from the reactor accident. With a lead housing in place, the Gamma Scout successfully measured the radiation emitted by this radionuclide. During a 24-hour measurement, this Gamma Scout with the sample counted 17,800 impulses. A background measurement for the same time yielded only 15,840 impulses. Radiation dosimetry is mainly using gamma radiation because of its long range, even through shielding materials. We have mentioned the term dose several times now, but now it's time to give some explanation. The idea of dose has been introduced as a quantity for risk originating from radiation exposure. The nature and energy of the radiation are of paramount importance in this context. The Gamma Scout, equipped with the GM tube, effectively measures pulses within a predefined time frame. However, it is not possible to determine the type and energy of radiation by using just this tube and its circuitry. The device is using a calibration factor to convert the count rate into a dose rate, establishing a correlation between the two variables. A problem now arises which definition of dose is used. One can calibrate for one particular radionuclide or for a certain type of dose called HP10, which is used nowadays in radiation protection. The difference is that the latter assumes a uniform effectiveness of the detector for gamma rays of all energies. This, however, is not the case for an end-window GM tube. Therefore, for the Gamma Scout, a calibration is provided for the gamma radiation emitted by cesium-137. Consequently, determining the dose rate for other nuclides introduces a systematic error. However, the numeric values are not too different, and increasing or decreasing dose rates can be observed in either case. Furthermore, it is essential to consider that, in everyday situations, alpha and beta radiation contribute negligibly to the external dose rate. That means the dose coming from the outside of our body. And on that note, we bid farewell and sincerely thank you for watching. If you've enjoyed this video, please give it a thumbs up and subscribe to our channel to stay tuned for all our future content. If you have any questions or suggestions, feel free to leave a comment below. We look forward to seeing you again next time. Until then, take care and see you soon.